Hi there. I would like to share with you guys some of the most common Agentic AI frameworks currently being used today. I hope you're already familiar with the fundamental concepts of AI agents. They are basically systems that can perceive, reason, act, and learn. Think of them as the next evolution from simple prompt response LLMs to truly autonomous, goal oriented entities. Just like in software development, where you choose between C for your low level control, C for your object oriented power, Java for the platform independence, and Python for rapid prototyping, similarly, choosing the right agentic AI framework is really crucial. Each framework offers a distinct set of tools and different levels of abstraction and control. Understanding this will help you make the right decisions for your next agentic AI project.
Let's explore the 8 most widely used agentic AI frameworks in today's industry. So, our table of contents are LangChain, LangGraph, CrewAI, Microsoft Semantic Kernal, Microsoft AutoGen, OpenAI Assistance API, LlamaIndex, and Google ADK. Let's go one by one. LangChain. LangChain is like a Swiss Army knife of LLM orchestration. What is it? If LLM application development could be compared to a general purpose programming, LangChain would be your Python, right? So it's incredibly versatile and widely adopted framework designed to simplify the creation of applications with your LLMs. It allows you to compose complex LLM workflows by offering modular set of components, like chains for sequence of calls, the agents for your decision making, memory for statefulness, and tools for external interaction. So when to choose LangChain, right? You need maximum flexibility and integration options out of your system. Then LangChain is your best option. You're building diverse LLM applications from chatbots and RAG systems to even complex data analysis pipelines, and you want to rapidly prototype and iterate. LangChain is your best bet. So the pros, the unparalleled ecosystem. It supports nearly every LLM provider, database, and API imaginable. Modular and composable. It builds complex agents by chaining together smaller reusable components. So it's easy to get started with. Massive community and resources. So there is abundant documentation, tutorials, and an active developer community for this LangChain. And rapid prototyping. It's excellent for quickly getting ideas off the ground. The cons can be, it can be verbose or complex. For simple tasks, the level of abstraction can sometimes be an overkill. Then there's the steeper learning curve for deep customization. So it's easy to get started with, but mastering it for the highly custom agents takes time. And there's the rapidly evolving API. So constant updates mean you need to keep up with the changes, right? Next, we come to LangGraph. LangGraph is the state machine for agentic workflows. It is an extension or a more complex version of LangChain. What is LangGraph? So LangGraph is building on the LangChain's foundations. It's like a C++ of agentic frameworks. It gives you the more low-level control of the stateful multi-agent systems, and the way it works is it represents the agent workflow as a graph, where nodes are the agents of functions and the edges define the transitions and conditional logic. So when to choose LangGraph? Let's say you need precise control over the flow of the multi-step agent interactions and each state of all these interactions, and you need your agents to remember context over long conversations, recover from errors, or involve human feedback. All those concepts, LangGraph is your best option. The pros are stateful workflows. It explicitly manages agent state. It's crucial for long running and conversational agents. Okay. Then there's the fine-grained control. So you can define complex non-linear flows with conditional transitions and loops. And the debugging and observability. The graph structure makes it easier to visualize and debug agent execution paths. And there's the human in loop natively. So what does that mean? It's designed to integrate human feedback within the agent processes. And the cons are increased complexity. The graph paradigm introduces a steeper learning curve compared to simple LangChain. Graphs tend to be a bit more complex and not easy for beginners. Then there's the dependency on LangChain. Yes, it has the leveraging ecosystem, but it inherits an underlying LangChain complexity in it. Then it is overkill for simple agents. If your agent doesn't require complex state management or multi-step reasoning, there's no point going with LangGraph. There are other better options for it. But overall, let's say you need good multi-agent communication and really powerful agentic system, then LangGraph is your best option. CrewAI, the team orchestrator. So what is it? If you're building agent teams that need to collaborate like human experts, CrewAI is your go-to, much like a specialized framework for microservices orchestration. It excels at defining role-based agents with specific goals, backstories, and tools, and then orchestrating them to work together on a shared tasks, often with a chief AI officer agent overseeing them all. So when to choose CrewAI? Let's say you're building multi-agent systems, where agents need to collaborate, delegate tasks, and share information to achieve a common goal. So that's when you're preferably using that. Let's say in research or content creation or project planning. The priorities are ease of setting up these collaborative dynamics of it. So the pros, it is intuitive multi-agent setup. It simplifies the creation of collaborative agent teams with clear roles. There's the human-like delegation. So agents can delegate and inquire among themselves, mimicking human team dynamics. Then there's the rapid prototyping for team-based AI. So you can get a multi-agent system up and running quickly. And the readability. The code structure is often very clear about the agent roles and tasks. You have mainly good communication between your agents. The cons are it is less flexible for individual agent control. It's more opinionated about how agents interact, which might limit highly custom single agent logic. Then there's the dependency on LangChain again under the hood. So while it presents a simpler API, it often relies on LangChain for the core components. And then there is only specific use case focus. It's best suited for collaborative team scenarios and less ideal for highly linear single agent pipelines. Microsoft Semantic Kernal, the enterprise integrator. So what is it actually? So Semantic Kernal is Microsoft's answer to integrating AI into existing enterprise applications, similarly to how Java focuses on enterprise solutions, right? So it's lightweight SDK that emphasizes semantic functions, plugins, memory, and it orchestrates to build intelligent agents and co-pilot experiences, that seamlessly blend AI with traditional code and data sources. When to choose it? So let's say you're a .NET or a Python developer primarily working within Microsoft's ecosystem, and your goal is to infuse AI capabilities, LLMs, into existing enterprise applications. Focus is on reusability, security, and context awareness. The pros, it is enterprise ready. There is strong emphasis on security, governance, and integration with Microsoft Azure and Microsoft 365 ecosystems. Basically, it's pretty easy to set up with your ecosystem. Then it's lightweight and performance oriented. It's designed for efficient integration into existing code bases without heavy overhead. Reusable AI components, it encourages modular skills or plugins that can be shared across various applications. And excellent memory management. It has built-in capabilities for context persistence, vital for conversational AI. The cons, it is less agentic in reality. So while it supports agents, its primary focus is on semantic functions and copilot patterns. or in other words, it's more focused on promoting or allowing AI solutions to integrate with your enterprise applications. Then there is the strong Microsoft bias. So while it's open source and flexible, its deepest integration and benefits are still within the Microsoft world, and it's evolving rapidly. So, being a newer framework, its community and breadth of example might still be smaller than LangChain. Okay. Then we come to Microsoft AutoGen. So this is the conversational automation maestro. It is another product of Microsoft, and what it is another framework for building highly customizable and conversational multi-agent AI systems. It's akin to a robust scripting agent for a multi AI interaction system, right? So it allows the agents to interact with each other autonomously or with a human intervention, often involving code generation and execution, making it powerful for complex automation and problem solving. Now, when to choose it? Let's say you need to automate complex multi-system tasks that involve agents discussing, planning, generating code and then executing it, and then also potential correction of errors. It's very good for those systems, and it's excellent for sophisticated AI driven workflows and R&D systems. The pros are it has a rich multi-agent conversation. It's designed for intricate conversational dynamics between your agents. Then there's the code execution and debugging. As we said before, agents can write, execute, and even debug their own code, which allows for powerful automation among it. Then there's the flexible human in the loop, so you can easily configure when and how humans intervene in the agent workflows, and scalability for automation, built with production and large scale automation in mind. The cons are it has a steeper learning curve, defining agent roles, the termination conditions and interactions. It can be complex. And then there's the configuration overhead, setting up this sophisticated multi-agent conversations, it requires careful configuration. And then it's resource intensive, running complex agent simulations can consume significant computational resources. Next, we have the OpenAI Assistance API, the managed agent service. So the OpenAI Assistance API is like using a fully managed cloud service for building basic agents. It abstracts away much of the underlying complexity, letting you define the agents with specific instructions, tools, and persistent memory threads. And it's ideal for quickly deploying powerful single purpose or multi-turn agents leveraging OpenAI's models. So when to choose it? Let's say you're primarily using OpenAI models and you prioritize the speed of the development and the ease of the deployment and manage infrastructure. And also you need persistent conversation history and straightforward tool integration without building complex orchestration from scratch. The pros, it's simple and it's easy to use. It abstracts away much of your boilerplate code for agents, memory and tool use. Then there's the managed infrastructure. OpenAI handles the scaling, the context window management and the state persistence. Then there's the native OpenAI tooling. So its seamless integration with OpenAI's code interpreter and retrieval tools make it much easier when it comes to the tooling part. And there's the persistent memory threads. So it has the built-in long-term memory for the conversations. You can store your history, you can connect your previous conversations pretty easily. Then the cons, it has the vendor lock-in. So it's obviously tightly coupled to OpenAI's models and ecosystem. You can't primarily use much other models with it. There's the less customization. It offers less fine-grained control over your agent behavior and orchestration compared to open source frameworks. And the cost implications, usage is tied to OpenAI's API cost, which can add up for complex interactions. Then limited multi-agent orchestration. It's primarily designed for simple goal-oriented assistance. Even though multi-assistant interactions can be built on top, it's limited to it. Next, we come to LlamaIndex. It's the data orchestration for your RAG agents. So LlamaIndex is essentially the specialized data management layer for your agentic AI, much like a powerful ORM or a data warehousing solution. While it started as a framework for retrieval augmented generation (RAG), it has evolved to support agentic capabilities by providing structured ways for the agents to interact with various data sources. It can be databases, APIs, documents, CSV files, anything, etc. And orchestrate the information retrieval for the complex queries. So when to choose LlamaIndex? Let's say your agentic application is heavily reliant on structured and unstructured data retrieval, maybe in the indexing and synthesis of large databases and data structures, and you need agents that can intelligently query and interact with diverse data sources to inform their reasoning and actions. LlamaIndex is your best bet. The pros: excellent RAG capabilities, best in class for the indexing, retrieving and synthesizing information from vast data sources. Then tool integrations for data, strong support for connecting agents to various data APIs, vector stores, and knowledge bases. It's the best with integrating all of that. Then multimodality, growing support for agents interacting with and reasoning over multimodal data. It can be text, images, all these multimodal data interactions are easily accessible and possible with these agents. And then the agentic capability built on data needs. So agents can leverage LlamaIndex's data pipelines for their decision making. The cons, its primary focus is on data. So it has agentic features, but its core strength still remains that data ingestion and retrieval. So general agent orchestration might be less comprehensive and less primary focus of it. And the better options would be LangChain or AutoGen. It can be complex for simple agents. If your agent doesn't have significant RAG requirements, it might add unnecessary complexity. Okay. And then next is Google ADK, Agent Development Kit. So personally, I have used Google ADK to build a few projects of mine. It is one of the easiest tools a beginner can start with. So Google ADK is Google's strategic entry into the agentic AI space, designed to be robust, production-ready framework for building and orchestrating sophisticated AI systems, particularly leveraging the power of Gemini models and Google Cloud. So think of Google's comprehensive platform play similar to how enterprise Java application server provides a full stack for the community. So the core philosophy is ADK aims to simplify the development and deployment of agents, and it does so by providing a structured code-first approach that integrates deeply within the Google Cloud ecosystem. It emphasizes modularity and interoperability. It works pretty well with the A2A protocol, agent-to-agent protocol, and a clear path to production. Pros of Google ADK: the native Gemini integration. So it's deeply optimized for Google Gemini models, offering access to cutting-edge performance and multimodal capabilities. Even though it supports other models, let's say of OpenAI, of Llama, Ollama, its best works with Gemini. And then there's the hierarchical multi-agent system. So it has excellent native support for designing complex agent teams with clear delegation and orchestration. So the idea is all the agents start with root agent, your main agent, and you can have many sub agents under it. But the idea is root agent controls all of them, and if you want another root agent, that's another ADK agent altogether. Then built-in evaluation and debugging. So it's pretty easy to get started with ADK, and the evaluation and debugging tools are very user interactive and user friendly. So an example is ADK web in your terminal spins up a local host with a good UI website to interact with your agent. And I am saying so because I'm a personal user of Google ADK in my personal projects. And the next pro is it has a rich tool ecosystem. So built-in tools, open API spec import, model context protocol support for connecting diverse enterprise data sources and APIs. It's very easy and very user friendly with all these extensive built-in tools. Cons of Google ADK: it is ecosystem specific. So while aiming for interoperability, its strongest features and benefits are realized only within Google Cloud ecosystem, potentially leading to vendor preference. Then it is newer to the public, being launched on April 9th, 2025. It is a more recent offering, and the community examples and third-party tutorials might be less extensive than older, widely adopted frameworks like LangChain. Then the learning curve for GCP integration. So developers unfamiliar with Google Cloud services might have an initial ramp-up period and potentially less community influence. As a Google-driven open source project, its roadmap might be less influenced by external community contributions compared to the purely community-driven projects. Okay. Coming to the conclusion, choosing your Agentic AI framework. So just like choosing a programming language, there's no single best Agentic AI framework. So if you want to value flexibility, a vast ecosystem, and rapidly prototyping across various LLMs, LangChain is your best bet. It's like your Python. And if you need fine-grained control over your stateful, multi-step workflows with debugging capabilities, LangGraph is your C++. And if multi-agent collaboration in team-like structures is your priority, with an intuitive API, CrewAI is your specialized framework. And for integrating AI into existing enterprise systems, especially within Microsoft ecosystem, then Semantic Kernal offers a robust, lightweight solution. And when complex, autonomous, multi-agent conversations with code executions and error and debugging systems are possible or are your goals and needs, then AutoGen is your powerful scripting agent. And then for simplicity, quick deployment, and fully managed service within the OpenAI ecosystem, OpenAI Assistance API is your go-to. And if your agents are heavily data-driven, requiring advanced RAG and interaction with diverse data sources, let's say LlamaIndex provides the crucial data layer and best options. And then finally, Google ADK is a strong contender, especially for those in the Google Cloud ecosystem seeking an enterprise-grade production-ready platform with hierarchical agent orchestration and future-proof interoperability. Now, each framework brings its own unique strengths to the table. Your choice will depend on your project's complexity, your team's existing tech stack, the specific problem you are trying to solve, and your deployment environment. By understanding these differences, you're well equipped to build the next generation of intelligent and autonomous AI systems. And thank you.